yourself.
Hi,
Thank you.
hi everyone, and I'm Mingwu, and I'm the co-founder and CTO of Conflex, and so I joined Conflex at 2018, and before that I was working in Microsoft Research Asia for about 11 years, and so Complex is a high performance layer one blockchain. It trying to achieve the best trade-off between the security, decentralization, and the performance. So without sacrificing any decentralization, and Complex can achieve the throughput at more than 3,000 transactions per second, and it can also confirm a transaction in less than half a minute. So its performance is much higher than the Ethereum and the Bitcoin. And yeah, so our the mission of our team is trying to push forward the state of art of the blockchain technologies. Yeah.
Okay, thank you so much, Yimei. Well, we all know like conflicts has been really famous lately with the Hong Kong conferences and all the events. So welcome to our next guest, Definity.
Hey, thank you, Pong. Thank you, the organizer for making this happen. So it's really great to share with you the latest from Divinity Foundation, also ICP. So my name is Herbert. I'm the general manager of Asia. I joined Divinity 2 years ago, right after we launched the mainnet Internet Computer Protocol. Previously, I was a head of startup for Amazon Web Services in a very ironic sense for Greater China, because AWS is a sort of the very big tech firm Divinity and ICP is trying to disrupt. So at Divinity Foundation, we've been around for a while. It was founded in 2016 by our founder Dominic Williams and also our chief scientist in Zurich, headquartered in Zurich, Switzerland. So since we launched our mainnet in about 2 years ago, the Internet Computer Protocol, our ecosystem has been growing very rapidly. So it's in a very high level nutshell, it's more of a general purpose blockchain for applications where you can host the front end of your web applications and also provide computation power with token and smart contract, etc. So we are really I think that 2023 is going to be a very exciting year for ICP. So can't wait to share what we have for you in a minute.
Awesome, thank you so much, Herbert. So for our next guest, we have multi-chain with Calvin today. Calvin.
Thank you, Paul. Hi, everyone. My name is Kevin, and I am a software engineer at Multichain. Before coming to Multichain, I worked at Hashkey. So Multichain is an assets bridge for tokens and NFTs. We were born as AnySwap on July 20th, 2020. Multichain builds a constantly growing family of EVM and non-EVM chains and deployed bridges. We have over 100 million billions in total volume and over 1.8 billion in total value locked. And we now support over 3,200 bridges and 81 chains. So we also have AnyCore and ZK router for in testnet, where ZK router is a trustless general cross-chain infrastructure. So it is our latest solution. So that's pretty much about multi-chain. Thank you, Pong.
Cheers, Calvin. I'm sure everyone like being the blockchain space has been using their products quite often. So thank you so much. So for our last guest, we have Izumi Finance, Jimmy.
Hey guys, I'm Jimmy from Izumi Finance. Yes, Izumi is a multi-chain liquidity service platform. We are building the most advanced DEX on the chain. Our DEX EasySwap adopts DLMM, which is you could think like Uniswap v3 plus on-chain order book. We want to build it on the high performance chains like ZK Sync. We are now the most active and the second largest DEX on zkSync. And we also want to explore more for the future of on-chain trading. Thanks.
Awesome. Thank you so much, Jimmy, for your introductions. All right. So let's not talk anything more. Well, we just get started with the AMA today. So there will be a few questions that we have prepared for our guests to answer with for today's topic. So the first one will be as more and more data is added to the blockchain, how do you propose to manage storage and retrieval, and what are the implications for network performance? So, is there any guesses? Do you have any idea that you want to share with our audience today?
Sure. I can give some of my opinions first, maybe.
Yeah, sure. Thank you.
Okay, so I think there are many ways that we can take to deal with the different kinds of storage problems. And because storage is a big area, we might need to combine many mechanisms to handle better the problems. So first, we know that many existing blockchain systems employ the Merkle tree-based structure for the storage of blockchain node to provide the capability of authentication, right? And this actually makes the storage access very slow and costly. However, there is still much room to improve access performance of the authenticated storage if we find a better way to redesign the data structure. So we have recent work that makes this improvement happen. And this work has been accepted by this year's OSDI, which is a top system conference in the world. In this work, and we designed some kind of a vector commitment protocol to update the commitment proofs in constant time. So we can significantly improve the access performance of the authenticated storage. And secondly, so when facing the problem of managing the massive traditional data, like the picture, audio, and the video data on the blockchain to give them the property of tamper-proof and permanent storage. And we have to resort to more scalable and decentralized solutions. For example, the Filecoin and the Arweave have taken an early step along this direction. However, it is far from mature and enough. So currently, they are mostly used to store the unstructured data for archive purpose, right? But the users may still need functionalities to access structured data. To process the data, we need a table, right? We need a database. So this will make data access easy. And but how to make the maintenance and access of these kind of data decentralized and manage them in an efficient way still needs many further researches to come up with innovative solutions. And the system like Arweave also lacks good integration with existing popular DApps ecosystems. For example, the Ethereum. So Arweave has its own wallet and address format, and its blockchain does not support smart contract. So it is not easy to integrate the data stored in Arweave into the Ethereum's ecosystem. So generally speaking, although the current decentralized storage systems leverage the blockchain technology, the data stored are not well integrated with the smart contract system on the blockchain. That is, a smart contract usually lacks the ability to directly access those massive data. So this actually requires new design of the entire system. So I think that's the right direction to go forward. And some other ways to address the massive storage problem may include the layer 2 app chain and sharding and so on. They share one common idea, that is offloading the storage workload from the single layer 1 blockchain to other places, and only using the layer 1 blockchain to resolve the minimal necessary workloads, like the verification of the data and operation on them. Comparing these methods, actually, I prefer the layer 2 and the app chain solutions because they are essentially doing the application aware data partitioning, so which I think is easier to achieve and more elegant. So sharding is trying to solve the problem by a system-wide solution, but the unawareness of the application behavior often makes it fail to minimize the cross-sharding data access. Therefore, it is hard to achieve acceptable performance. Yeah, so that's basically all of my opinions on this question. Yeah.
Okay, I just wanted to be make it clear, like the stage don't have to be that tense, and if there's any guesses you want to share your opinion, just feel free to come on the stage and yeah.
Yeah, I can. Hey, Bon, I can. I think I can follow up next.
Yeah.
I very much agree with Ming just said that data storage in crypto industry has been a problem, and it requires a very different approach to solve that. So in Divinity Foundation and also Internet Computer Protocol, all the developers we have in the ecosystem, we have a fairly simple solution to that. Well, you can store your data on ICP. It's very simple. For example, a lot of developers are already doing that. In the past, the NFT JPEG pictures have to be stored on one of the IPFS providers, such as Filecoin or Arweave, or worst of all, 70% of them probably stored on AWS, EC2, or S3 servers. But with ICP, you can run your entire web application, front end, back end data on chain. So, for example, one of the more interesting startups from ICP ecosystem from actually China, it's called a MetaBox. It's very similar to S3 in the AWS, where you can upload data, whether it's an audio file for this Twitter Space broadcast, or like a video file up to the size of, I think they can handle up to 300 megabyte size file. You can upload that to ICP, and then play that on a web page and share that on social media, no problem. Another interesting application will be Mora.app, which is called Mora, which is for a lot of us basically the terminator for Mira, Medium, Patreon, and also Substack. So as a content creator, if you are a writer, you can publish your contents, you can create your contents, store them on the Mora forever. In what they call planets, and you own the entire data. You have the entire 100% data ownership for everything you publish, and you can charge subscription fees from your followers. So all that is possible now on ICP, and another startup in our ecosystem called Itoka Music, that is trying to basically become the Spotify on IC. They recently did a test involving more than 1,000 testers around the world from 70 plus countries to test the speed of data storage and retrieval, where they stream music through a canister smart contract from ICP. So the result was very interesting. So basically, Itoka plus ICP's performance actually beat all the major technology firms from Amazon Music, Apple Music, Spotify, Pandora, YouTube, and even SoundCloud. On average, Itoka can achieve a download speed of 2.74 megabyte per second. And compared to say YouTube is only 0.26 around the world. So data storage on ICP has been a huge advantage for a lot of developers because we use something called orthogonal persistence. There is no more file system on ICP. Everything is stored as a state in the variables. So which is a very different way of structuring your entire application. I'll leave it like that, but happy to answer more questions if there are more from the audience. But that's how we handle this whole data storage issue in ICP.
Awesome. Thank you so much, Albert. Do Calvin and Jimmy have any thoughts to add on to that?
Sure. I pretty much agree Ming Wu's opinions about the sharding way and the app chain ways. So before these two things, I also want to mention modular blockchains. So modular blockchain is a type blockchain architecture that allows developers to customize and configure different components of the blockchain to suit their particular needs. The modular approach breaks down the blockchain into smaller, more manageable parts of modules, which can be updated or replaced independently of the rest of the system. And aside from that, modular blockchains architectures are designed to be flexible and adaptable, making it easier for developers to create customized blockchain applications to meet their specific requirements. There are also several benefits to using a modular blockchain approach, like scalability. The modular blockchains can be scaled up or down as needed by simply adding or removing modules without affecting the rest. And security, about the security, by breaking down blockchain into smaller modules, it's become easier to identify and address any security vulnerabilities or issues that may arise. So I think all of these solutions come with their own trade-offs, and they may we can also utilize them together, right? Such as increasing the complexity or potential security risk. But as the blockchain technology continues to evolve, it will be important to find the right balance between security, scalability, and performance to ensure the continued adoptions of blockchain technology.
Yeah, I think most of our guesses get our guesses informations just now. I don't know if there's any connection drop with Calvin or hi Jimmy, you want to add something onto the topic?
Sure. I just want to add one more thing. I think for the storage, the space for the blockchain is quite expensive and also very. We need to take it in cautious ways to make the best use of it. So as for DeFi protocols of Izumi, actually we need to decide which part should be on chain and to be stored on the chain. In my opinion, I think all the transaction data and also the data that may affect the asset and also the transparency, the account should be fully on chain. So that's why we want to build the order book fully on chain, the on-chain order book DEX. But meanwhile, there will be some other data like the analytics data and also some accounts data, especially which may affect personal information. Maybe this part of the data should not be stored on the chain directly. And we are now building on the ZK Sync, on the ZK rollups. So layer 2, I think, will be a good way to store some data instead of to make all the transactions happening on the Ethereum mainnet. So it's cheaper. And meanwhile, with the ZK rollup or the OP rollup solutions, the transactions and also the asset data could be secure and could be safely kept in certain level. So that will be enough for part of the trading. So we don't need to store all the data on the Ethereum mainnet, but we could also store the data on the layer 2 or even layer 3. Yeah, so that's some things I want to add. Thanks.
Okay, thank you so much, Jimmy, for the last add-on to these questions. And thank you for mentioning for ZK proofs that you just mentioned with you guys are going on to ZK Zinc chain as one of our questions have something related to ZK proof. So I'll bring on to that topic first. So the question is actually about how do you see the integrations of ZK proofs with other emerging technologies such as AI, IoT, and cloud computing, and what implications does it have for the future for blockchain-based systems? So, Jimmy, if you have anything that you can add on to this topic, and other of our guesses?
Sure, I could make a start. In my perspective, I think DK proofs make some data to be more valid. because we all know that for the layer two, for example, for the layer two, the most of the data are decided by the sequencer, and also some data like the OP rollup, they use the challenging mechanism to make sure the data is recorded correctly and also in the right order. But with the ZK proofs, actually, it could make the data that everybody could get access to be more valid and also to be trusted by more people. And in the meantime, in some mechanisms, people could not to reveal the real data or the original data, but in the meantime to get the results of it, to believe the results but don't know the data source. I think that will be quite important for the privacy, and also for some to simplify some of the confusing transactions. So this is from the trading and also the liquidity view, but come together with the AI or IoT or cloud computing. I believe there will be more to do, but I'm not the expert of that, so I leave these questions and topic to other guys. Thanks.
Hey, Pon, I can add something to this topic.
Yeah, just go. Please.
Yeah. So ZK is an interesting topic, right? There has been a lot of great progress in the industry on ZK related techniques. ZK Sing, as I think as Jim just mentioned, and all that. But I don't think it should be seen as a silver bullet. It does not and won't be able to solve every problem. But so we just need to be cautious to the hypes and in the crypto industry right now. There's a lot of ZK talks right now, maybe a little bit too much. At Dfinity, we the ZK zero knowledge proof has been embedded as part of our most basic infrastructure protocols, that is non-interactive DKG protocol. So if you guys, I think there are a few hundred listeners out there. If you are a cryptographer or a researcher in this area, you must have heard of Young Scrolls. Young Scrolls, who in 2016 published the now widely called as the Growth 16, the ZK snark technique. So Young Scrolls is a director of research based out of Zurich from a Dfinity Foundation. I think a few days ago, Young's just won another Test of Time award from IACA, the International Association for Cryptologic Research. I think this is the second time Young's has won this award. So ZK is something that a lot of researchers in the Dfinity Foundation, we are actively exploring use cases for. Like one of the early pioneers in our ICP ecosystem is called Spinner Cash at Spinner dot Cash, where this new startup, anonymous startup, they create a service that uses zero knowledge to provide private transactions between the ICP and the Bitcoin. So there are more cases coming, but it's pretty exciting area. I think from Dfinity as well as a lot of developers for ICP. But it's just we gotta be cautious of how many problems it can solve, especially now with the rise of AI, Midjourney, and Stable Diffusion and all that. So I'll just leave it at that. Wow.
Awesome. Thank you so much, Robert. Does anyone of our Ming, you
Sure. Yeah. I can share some of my thoughts on these questions. So I think introducing ZK to these general computing areas is a good direction to go for. It may help decentralize these general computations, which will significantly enlarge the application scope of the blockchain technology. Although currently there are still many technical challenges and performance bottlenecks when applying ZK to complex computation, the development of this technology looks very promising, I think. Besides the evolution of ZK algorithm itself, I think there are several important technologies to help advance the development of this area. One is the hardware acceleration for the specific ZK algorithms. This may significantly increase the efficiency when applying the techniques in practice. Conflux actually has some early strategy along this direction. So we have a partnership with a startup called Axio, who is working on the hardware solution for the acceleration of ZK algorithms. And the other direction is the programming framework of the ZK algorithms. So this may accelerate the development of ZK program and make it much easier to apply ZK in many places. Yeah, that's my answer to this question. Yeah, thanks, Pong.
Jasmine, Kevin, do you have anything you want to add to this topic?
Sure. I think by using ZK proofs, it's possible to verify the correctness of computational data without revealing any sensitive information. So that's the key part. So it can be useful in a variety of use cases across different industries. So I think blockchain with ZK proof will be a good solution for communications between some automated machine clusters. So currently, in some cities in China, there are smart factories emerging. They are using a combination of advanced technology like IoTs, 5Gs, but usually they are all inside one company or one business. So they don't have a trust problem. So I think in near future, these smart contracts, these smart factories among multiple businesses will become a reality. Actually, some already are in some supply chain industries. Some of them are already using blockchains, but we call them consortium blockchain or alliance blockchain. They face the problem of inefficiency. But I think with ZK proofs, the trust problem and the efficiency problem will be completely okay to solve. So that's my idea about it. Thank you.
Awesome. Thank you so much, Kevin.
Hey,
Well,
hey, Pong,
yeah,
can I add something to this topic?
yeah.
Yeah, so I think for zero knowledge, I guess one of the more popular online classes on cryptography in general is the one developed by Dan Bonnet and Victor Shoup from Stanford University. Well, Dan is from Stanford and Victor is in New York. And also Victor Shoup is another principal researcher from Divinity Foundation. So this is a highly recommended, a really good graduate course in applied cryptography that is free, so anyone can just get started. And speaking of Dan Bonnet, I think Dan Bonnet a few months ago had a very interesting podcast with the Zero Knowledge podcast to talk about the use cases of zero knowledge. I think for anyone out there interested in ZK, I think that podcast is again, I think highly recommended. A really good, starter on what ZK can do to solve like real life problems, such as if you see an image from New York Times, can you trust that image? How do you prove that image was taken with a verified timestamp at that point for that particular context? Now, with the rise of AIGC and ChatGPT, it's actually the line is getting very blurred. It's actually become a very big challenge. But I think Dan Bonnet's online class, as well as that podcast, could be very useful materials on the ZK topic. Yeah, thanks, Paul.
Awesome, Herbert. Does any one of our guests have anything to add it to this topic? If not, then I'll move on to our next questions. So, how do you see the integrations of different blockchain networks and protocols developing in the future? And what challenges will need to be overcome to enable interoperability?
So yeah, I can share my thoughts first, maybe.
Sure, thank you.
Yeah. So I think this is a very important problem since there must be multiple blockchains coexisting in the world, and the asset liquidity will be much fragmented if they cannot interoperate smoothly. So we have seen many bridge protocols being designed and developed to handle the interoperability of multiple chains. Most of them are seeking for the best trade-off between the security and the efficiency. The security of the bridge is very important, so I think we should not sacrifice any security. So we should find a solution to achieve as high efficiency as possible, given the strong security guarantees. So some early solutions take the pure off-chain methodology with off-chain nodes running by a consortium, and these nodes verify the events on the source chain together through the multi-sig. Although this method does not involve costly operations on-chain, its security relies on the reputation of the consortium, which sacrifices the decentralizations. So these decentralization issues are further mitigated by letting these nodes form a decentralized network, and they stake some assets as collateral and verify the behavior of each other. If some evil behavior is discovered, the stake of the evil node will be slashed as a penalty. So in this method, the main issue of to resolve is to maximize the utilization of the collateral assets. And another line of solutions is to use on-chain verification, which requires the light client logic implemented in the smart contracts and running on-chain. Through this way, it decreases the reliance on the security of the off-chain relayers, but at the same time, it increases the complexity of the on-chain verification logic and also introduces extra engineering cost. One project called Layer Zero tries to simplify the on-chain verification by offloading part of the verification logic to the Oracle and assume the Oracle and the relayer will not collude. However, this security assumption is often criticized by many practitioners in this area. So recently, some ZK technologies are introduced in the bridge area to make the on-chain verification easier, but it also causes a large overhead at a proof generation side, which may lead to the long latency of the cross-chain operation. So I think a more promising methodology is a hybrid of integral on-chain verification and a optimistic way through decentralized network of off-chain nodes. So the optimistic mechanism will achieve the fast delivery of cross-chain messages, which may be followed by a relative slow process of the later fraud proof with the stakes slashed as a penalty. In addition, I think another way to address the interoperability of multiple chains is to decrease the demands of the cross-chain operations as much as possible by transforming those operations to the ones happen on a single chain. This can be achieved through a novel technique employed in Conflux, which is called a virtual space, for example. So that is we run multiple logical chains on a single physical chain. So the logical chains share the same blockchain ledger but have separate VMs and states. So ideally, we can implement multiple logical chains compatible with different ecosystems, for example, Ethereum, Aptos, Solana, and so on. So recall that one major purpose of the interoperability is to allow the interactions among different ecosystems. So through the virtual space technology, we actually enable the users to just cross-chain once and interact with different ecosystems through the cross-space operations later on, so which are much more secure and efficient since cross-space operation is a single transaction on a single chain. Okay, so that's all my answers to this question. Thanks, Paul.
Hey, Pon, I can follow up on that.
Yeah.
So this is a great question, Pon. I think that interoperability is probably the most important theme for the Internet Computer Protocol roadmap in 2023. So last month, we just launched a new feature. It's called a BTC, a Bitcoin and ICP direct integration, which will essentially enable smart contracts on BTC. And in a few months, we are planning to complete another major milestone, that is Ethereum and ICP direct integration. So let me elaborate a little bit. So we're not talking about bridges here. Bridges are bad. Bridges are vulnerable. Eventually, all the bridges will be rug pulled as when the stake is high enough. So in Divinity Foundation, we don't believe any bridge-based solution is going to persist. So our approach is to use a version of the threshold ECDSA, and also, as mentioned earlier, the non-interactive distributed key generation and key sharing technique developed by our cryptographer teams to essentially to achieve a direct integration of say between the ICP mainnet and the Bitcoin. So how does it work is if you run a smart contract on ICP, you will be able to make API calls that can control essentially a wallet address on Bitcoin. Or another way to understand is if you initiate a transaction, you sign the contracts, you sign the transaction from ICP and send that over to the Bitcoin mainnet. It will be recognized as a native Bitcoin transaction, and then Bitcoin transaction can send it back with also its signed and verified signature. So that really unlocks a lot of use case scenarios. So now we have a version called a CK-BTC. CK stands for chain key technology. So CK-BTC has a one-on-one relationship to BTC, but it's a lot faster and it's a lot cheaper. Because on one thing to, as you mentioned, for ICP network is we have this reverse gas model where there is no gas fee, right? There's no gas fee, period. So it will be a lot easier for users to send CKBTC for tipping, for reward, for user rewards in the community, etc., and do a lot of very complicated financial transactions with Bitcoin wallet address with this feature. So one of the trendy startups during the recent Web3 festival in Hong Kong from our ecosystem is called Astra X. Astra X team just developed this card. It's almost like the size of a business card. It's called Astra Card that has NFC enabled. And what it does is it uses a CKBTC technology so that you can essentially store and also send CKBTC just from your cell phone, from the wallet on your cell phone. So that is pretty revolutionary, and a lot more is happening in our ecosystem. Another one in the US, they just launched an NFT marketplace using this CK-BTC technology, so that eventually we can do a ordinal NFT for Bitcoin, but through smart contracts on ICP as well. So that is BTC, and the team, our R&D team, is working on this Ethereum integration. As a lot of our users know, in the past this has always been a challenge because ICP was not compatible with EVM. So with this integration that is expected to be completed in the next 3 to 4 months, ICP will become EVM compatible, which means all the ERC20 compatible tokens, all the TVLs from the world of Ethereum, Polygon, Arbitrum, and all that, eventually will be able to come to IC ecosystem as well. So if you're a Solidity developer, you will be able to deploy your smart contracts directly on IC. So that's pretty exciting for all of us. Another UK-based startup called Infinity Swap. About a month ago, they just created a EVM on IC, basically a EVM running in an IC canister smart contract. So if you want to redeploy any existing contract, say from Arbitrum, you don't need to run another layer 2 network anymore. You just need to deploy that into a single smart contract on IC. So I think there's a lot more to come in the next few months in IC. So I welcome all the developers to come over and take a look. Yeah, thanks, Paul.
Cheers, Herbert. Kevin and Jimmy, do you have anything you want to add on to that?
Yeah, definitely. The work of integration of different blockchain and protocols is what multi-chain has always been working on. As we will continue to do better. Multi-chain is maybe well known for cross-chain asset swap. But last year we introduced Anycall, a generic cross-chain messaging protocol which can send cross-chain messages and call smart contracts from one chain to another. It enables the easy calling of contracts native to one blockchain from another to any other blockchain. So we have several use cases. Of course, we support the cross-chain asset swap still, and we also have other use cases like permissionless fungible token and NFT bridge, cross-chain gas swap, and cross-chain oracles. Currently, we have Anycall version 7. It is it intensifies exclusive fallback function to support more complex and innovative dApps. So currently it has 14 EVM chains support. And Anycall infrastructures building, we have Anycall website, debug tools, and SDK toolkit. So there will be more to come, like Anycall expansion to more EVM and non-EVM chains like Solana and Aptos. We are of course we already have the asset cross-chain to support on these two chains, and we also have an innovative use case powered by Anycall, projects powered by Anycall that can that are incubated by multi-DAO Anycall. There are also Anycall hackathons will come in. So with Anycall, I think anything can be interoperable across any blockchains in just one single process. Yeah, thank you, Peng. That's my idea about it.
Cheers, Gavin. Jimmy, do you have anything you want to add on to that?
Yes, I think like as for DeFi's projects perspective, um, building the smart contract on one chain is we could make it definitely quite safe. Quite safe, but when we want to bridge some assets to another chain, and also to maybe to call the message from another chain, there will be a lot of uncertainty and risk. So we are thinking about some solutions which we could learn from the CeFi. There are some custodian companies that they are providing the super loop solutions. That means some traders they could just deposit their money into the custodian in the like in a MPC wallet. And meanwhile, the different chains, the different centralized exchanges will issue the credit to the trading firm to get the credit into their account for them to trade. And if the trading firm lose money, the MPC will send the tokens deposit into their account, send the money from their account to the centralized exchange. And if the trading firm earn the money, make the money, the centralized exchange guarantee that they will send the token to the MPC wallet. So it is called super loop. So in this condition, actually, the principal don't need to be deposited into every centralized exchange, which could avoid the like rug pull risk, and also to make the principals safely kept into the multisig wallet. So this solution has been adopted by more and more centralized exchanges, especially after the FTX collapse. So we are thinking about whether there will be some similar solutions, that is to make the asset to be safely kept and used on multi chains, well to keep risk of the like the interchain risk. So maybe we could learn from the super loop and to build something on multi chains. So like for every chain, they could get a credit for the to light some whale LPs to deposit their liquidity onto the a well trusted chain like Ethereum. And meanwhile, they could get a credit and also to be used on every chain. And this could be like all of the assets will be kept into a set of MPC and maybe some other more secure modules. And the liquidity could be kept on the mainnet, but meanwhile, the traders could get a credit to debute on every chain. So this could be help the whale LPs to get rid of the risk of the like the potential hack risk of the bridges, and also to make the best use of their liquidity to improve the capital efficiency. So there are some other ways we could learn from CeFi to make into Web3 and multi-chain scenarios to increase the capital efficiency, and meanwhile to improve the interoperability. Yeah, there's just something come to my mind. Maybe if we get some holistic solutions, we could share with all of you. Yeah, thanks.
Thank you, Jimmy. Thank you so much, Jimmy. Uh, all right, let's move on to our next questions. So our third questions is going to be, what is your approach to consensus mechanisms, and how do you propose to address issues of centralizations and scalability that may arise with certain approaches? Anyone?
I can go ahead first. And
Yep.
so in Conflux, we currently solve the consensus bottleneck through our novel blockchain ledger structure called a tree graph, and the consensus algorithm on it, which is called GAST. It essentially provides a method to allow a faster block generation rate in the entire decentralized network, and still guarantees that the secure consensus can be achieved. So the high-level idea is that we break the reliance of consensus algorithm on a single chain structure of blocks and allows it to include all the blocks on the forks to consider them to be valid through the help of a graph structure. So since the blockchain is a complex system, it contains multiple components to work together. After removing the consensus bottleneck, the new bottlenecks may surface. For example, the network bandwidth and the execution of the VM. So we further invented other techniques in Conflux, like fast transaction relay protocol and efficient Merkle tree storage to resolve the bottleneck of the other parts. So the scalability of a single layer one blockchain will definitely have a upper limit. So if we want to achieve higher scalability, I think layer two app chain solutions are the reasonable ways to go. However, these solutions still need to resolve the centralization issues existing in the interaction with the layer one. For example, for layer two, the sequencer may have the centralization issues, and for the app chain, the centralization issues may exist in the bridge. So we need better technologies to address these problems. I would like to discuss more about the layer two here. So many people may think that the layer two has close relationship with Ethereum, but this actually comes out from the non-technical reasons. So technical wise, the layer two can integrate with any layer one blockchain to use it as the settlement layer. And connecting with more efficient layer one should be better for the layer two to provide a higher quality service. So then why current layer two stories are mainly about Ethereum? This is because to successfully bootstrap a layer two project, it needs the support of the Ethereum Foundation or Vitalik on fundings and advertising. So therefore, a layer two system must use ETH for gas for settlement, and this actually causes some conflict of interest between the ETH and the layer two's own token, right? So if the layer 2 project promotes the value of its own token too much, it may lose the continuous support of Ethereum Foundation, I think. So this eventually will limit the market cap that the layer 2 project can really achieve. So people may not imagine the market cap of a layer 2 project can reach the similar level as Ethereum, right? But I think layer 2 can have higher scope. So to realize that, I think layer 2 needs to proceed independently and escape the limitation and the dominance of Ethereum. It needs to grow to be mature enough to be able to freely choose the best layer 1 to integrate with. So there are many excellent layer 1s existing in the world currently. So Conflux sincerely welcome any strong layer 2 technologies to integrate with and co-develop our ecosystem together. Yeah, that's my answer to this question. Thanks, Paul.
Hey, Pon. I think from Definitive Foundation, also ICP, our consensus mechanism is called a POUW, Proof of Useful Work. So it's neither POW nor POS. We think both are pretty bad. So we have this proof of useful work where if you imagine ICP as a decentralized version of AWS, it will become much easier to appreciate the beauty of this. Basically, ICP is a giant virtual machine that connects a lot of independent data centers around the world. There's no reliance on any centralized cloud servers, unlike AWS or Azure or GCP. So in this setup, like each independent IDC providers, they provide SLA, data storage, computation power, and all that to all the applications running on ICP, and then they get paid by the network. We call it NNS, Network Nervous System, which is a massive DAO. And then they get paid by this DAO for providing the useful work. So that's how, in a very, very highly simplified version, how our consensus works. But then I think when you, Paul, when you ask a question about consensus, this is really, technically speaking, it's about the permission mechanism, about how to onboard a new node into the system. Right. Another thing we from Definitive Foundation we have made very major progress in recent months is that now any individual, well, mostly it's unlikely going to be an individual, any entity can now apply to become a node provider on IC. The entire process is autonomous. In the first year after we launched our mainnet, it was a manual process where there were a few hundred of entities on the wait list globally, and we could just never get to that. But with this new onboarding process, now it's the whole application process is entirely autonomous. So welcome, if you have resources at like an independent IDC center, we welcome all of you to apply. Especially we need to run more nodes in Asia, like ideally outside of Hong Kong, so that it can serve customers, retail or enterprise from mainland China. So that's on the node operation part. Maybe I should share some numbers just so that for the uninitiated developers into ICP, you get a peace of mind if this thing gonna deliver in the end. Our finalization rate is 1 to 2 seconds. If you are running an update call, if the API is going to change the state of the variable, it's going to be between 1 to 2 seconds. And if you run the query call, which only to query the state without changing the state, our finalization rate on ICP is between 100 to 200 milliseconds. And right now, I'm just reading the live data from our dashboard.internetcomputer.org. We are producing new blocks every second at a 37.5 blocks per second. That's pretty fast. So So to run a node, to run an application on ICP, that is, you can pretty much migrate your existing Web2 applications to ICP. I also want to mention about the consensus mechanism. Back to the original question, which is actually not a. It takes a non-trivial answer to really clarify that. A major difference between ICP and Ethereum, let's say, a lot of other layer ones is it only requires 48 bytes to produce a hash that can verify the entire history from Genesis block. While on the equivalent number on Ethereum, last time I checked this, that was March 2021. The data will require something in the range of 400 gigabyte, 400 gigabyte. And the reason we are able to do that is because of, again, coming to this multiple non-interactive DKG. So the key is every time you have to generate a key randomly. But then with our variation of this non-interactive DKG, we're able to always produce the same public key. So that's the trick. So that no matter how interactive this is, even though every time it's perfect randomness, but in the end, like all the nodes, usually we have 13 nodes on any given subnet. They will form a consensus that is essentially the public key of this entire subnet. Well, subnet in other blockchains, that's Ethereum called it sharding and all that, but essentially it's a subnet. A subnet is a separate. It's just another independent blockchain. That's how we solve the scalability issue. So with this technology, will be if you are a bad actor, you won't be able to hijack the network unless you can control more than 1/3 of all the nodes. So that is our fault tolerance. So what does it mean for for another developer running the application that wants to interact with a smart contract on ICP? You don't have to trust any individual nodes. You don't have to, because we don't believe anyone is going to be honest. But all you have to do is to trust the subnet where a consensus is formed among the 13 nodes. That's the only trust you have to place. If you can do that, then and you can rest assured there will be no malicious attack on the other side of the transaction. So this is a big topic. It requires a pretty extensive and probably boring technical explanation. But I will stop there. Thank you, Paul.
No, thank you so much. There's so many information that is bringing to brainstorm myself, and I learned so much from you guys. So because I'm not really a tech guy, but yeah, really appreciate for you guys' answers. So Kevin and Jimmy, do you have anything you want to add on to these questions?
No, from my side.
Okay. Although multi-chain is not a blockchain like other like Ethereum or Bitcoin, but we do face the issue of centralization and scalability in our signing scheme, which is SMPC. SMPC is short for Secure Multi-Party Computation. It is a cryptographic technique that enables multiple parties to compute a joint function of their private inputs while revealing nothing but output. So we use this to ensure our users' security. So we might have some potential solutions to address this, address the centralization or scalability problem in our signing schemes. One is to use hardware acceleration. So specialized hardware such as secure enclaves or trusted execution environments can be used to accelerate SMPC computations while maintaining the security and privacy. And we also considering to use some layered architectures because SMPC can be combined with other technologies such as sharding or layer 2 scaling solutions to improve scalability and reduce the burden on the network. By dividing the workload into smaller parts or offloading computations on site on other machines or state channels, the overall throughput will be increased. Yeah, that's my answer to this question. Thank you, Peng.
Awesome. Thank you so much, Kevin. Well, so finally we'll bring to our last two questions. So this question will be, how do you see the development of quantum computing impacting the security of blockchain-based systems, and what steps are you taking to prepare for this eventually?
I can go first.
Yeah, thank you.
Yeah. So I think we do not need to be overly worried about the threat of quantum computing on blockchain security. This field is still immature. Throughout the development history of quantum computing, there are only two quantum computing algorithms that are recognized as practical currently. So the first and the most famous one can decompose a large integer, or what we call a Shor's algorithm, to find the period in the group. So this algorithm has an exponential advantage over the classical algorithm and can be used to attack the RSA algorithm and the elliptic curve encryption and signature. And the second is the Grover's algorithm for searching. So this algorithm has a square quantity level acceleration. For example, if the original time is n, this quantum algorithm only needs a square root of n time. So quantum computing has yet to show advantage over classic computers for almost all other meaningful, non-deliberately constructed problems. So this is also the most concerned issue in the field of quantum computing in the past 3 decades. So even if there are high performance quantum computers now, the biggest impact is that the RSA encryption algorithm and the ECDSA signature algorithm are not safe, and they need to be replaced with other encryption and signature algorithms. So in fact, we already have many algorithms that resist quantum computing attacks, but because there are no quantum computers currently, so everyone is too lazy to change them. So when the quantum computer is made, everyone can replace it with new algorithms. So for general computing problems, including finding collisions of hash functions, so quantum computers do not have a clear advantage. That is to say, it is impossible to find the collision of a hash function in short time with a quantum computer. Returning to the question of the progress of the quantum computers, so according to the current level of Google's quantum chips, how long will it take for quantum computers to break through the RSA encryption algorithm used in reality? Take the RSA algorithm with a key length of 2000 bits as example, so which is actually the lowest security standard currently used, right? And it requires about 3,000 to 4,000 logical qubits to break. So Google's current chip has reached 60 qubits, and according to Moore's law, it seems that it will take less than 10 years to break the RSA. But in fact, Google's chip implementation only implemented the physical qubits, not logical qubits. So the physical qubits are usually affected by the external disturbances and cannot be directly used for the complex calculations. So if you really want to calculate, you need to organize many physical qubits together with quantum error correction code to form logical qubits before you can use them. According to the error level that can be achieved now, tens of thousands of physical qubits are required to realize one single logical qubit. So yeah, so that's the current situation. So I don't think the threat is too serious. But of course, we need to keep observing the progress of the quantum computing area and be ready to upgrade our blockchain infrastructure with the quantum resisting algorithms when threats become more real. Yeah, that's my opinion. Yeah, thanks, Paul.
Hey, Pona. I was afraid you're gonna ask this question on quantum computing resistant algorithm. It's a fascinating topic, but it's not something that we lose a lot of sleep. In Divinity Foundation, it's not on our roadmap yet. But it has been floated as one of the ideas, suggestions from the community. The sort of the TLDR version we have is, yeah, we don't we do see that as a threat in the next couple of years, but right now we just have much bigger fishes to fry. The integration with Ethereum, how to split the subnet, how to decentralize our edge networks and all that. But And also we have some of the best cryptographers and researchers in the world that we believe. Well, I know this sounds like a cheesy answer, right? We have the best team so that we can handle this, but it sort of is the answer. Our CTO, Jan Kamenisch, who is an IEEE fellow, who used to run the IBM lab based out of Zurich, where IBM is one of the forerunners on quantum computing. And also, as mentioned earlier, Jan Gross, our director of research, and also scientists such as Victor Schub. They are the foremost experts in this area. For example, even the Gross 16 algorithm is not resistant to quantum computing to quantum computing attack, but it's actually take a pretty substantial effort for Divinity to replace that. I can be more detailed about that. For example, we well, okay. Let me take it one step back. In terms of the horizon, a small subset of experts in the industry feel that the attack could be imminent within the next 5 years. But people are very divided about when this is going to happen. But we do want to maybe start this effort earlier. But it's hard because let's just break down, like, what does it require to become quantum computing resistant for a typical layer one blockchain. For example, the existing key primitives such as AES and SHA, usually they are believed to be post-quantum secure, right? So that part is fine. And for public key encryption, right, the current front runner is lattice-based cryptography. I think the Min just mentioned this as well. So for signatures that are both lattice-based and also hash-based candidates, then we need to evaluate how to handle them differently. For example, lattice-based signatures could be more versatile in building more sophisticated signatures. I mean, a different version of threshold signatures that is probably different from ECDSA that is very widely popular now in the industry. So we have to really look at the different components of what constitute the protocol layer of a blockchain, and then to see how we can tackle them. And also, there is I want to highlight that there is a belief among some of the people in the industry that if something is post quantum secure, then the whole thing is secure. That is not necessarily the case. So we have to make sure whatever scheme that we end up choosing, maybe a few years down the path, that will be post quantum robust enough, that is also secure enough, because one does not necessarily equal to the other. So we have to be really careful about this, and that is a non-trivial effort, I think, for any foundation to undertake. And some of them, I think, probably can be some of the efforts can be undertaken by the community. For example, some of the hash function and the TLS, maybe that part of the work could be done by the community developers, not necessarily from from Dfinity, but some of the more complicated, such as multi-signatures and the threshold signatures, that is not something that can be easily handled by developers from the community. Usually, it will be done by probably someone out of Zurich. So that's sort of a long, winding answer to this question. It's an important topic. We need to study effort early, but not necessarily something we lose a lot of sleep in the short term, because we have a lot of other things that can be done to enable our developers. Yeah, thank you, Paul.
Awesome. Cheers, Herbert, and also Ming. Well, regarding to that, I know it's not something that is coming close to what we have right now today, but for the upcoming future, who knows, like what quantum computing might come into the play with blockchain technologies, or even like other technologies that come into play in not Web3 or Web2, or even like maybe Web4 in the future. Who knows, right? So Calvin and Jimmy, for the last thought, you guys, do you have anything you want to share?
Not too much. I think we have the consensus that quantum computer is not yet a threat to blockchain. As far as I know, any of the asymmetric encryption algorithm based on elliptic curve or large prime numbers are not post-quantum. So like ECDSA, EDDSA, KZG, all of them are not post-quantum. But it's not what we need to worry about now, right? So if one day quantum computing just emerge, I think including Ethereum, if changes not happening, and most of the Web2 service will just break. So I think before quantum computing happen, really going into heavy use, we don't need to worry much about it. So that's my thoughts about this question.
Awesome. Thank you so much, Calvin. Jimmy, do you have any last thought you want to share?
Yes, I'd like to add on one point. I think the security is the most important thing for the blockchain communities. And as for quantum computing, I think we need to keep an eye on the technical breakthroughs of it. But meantime, I think there will be different kinds of consensus algorithms and also consensus mechanisms. So don't need to be agree with Mingwu, and we don't need to be too worried about that. And yes, that's all for my side.
Awesome. Thank you so much for of our guesses to answer the questions that we have prepared. And last and quick questions for of you. So is there any personal view on the upcoming market trends that you can share with our guests? I mean, our audience today? Just like quick share will be fine. Lizo, I saw you were raising hands. Please bear with us. There will be the final.
Yeah, I'll quickly. I think just quick words for sharing is please all the developers in the Ethereum, if you're out there, please check out Dfinity Foundation and this upcoming Ethereum integration. It's really exciting. So we are hoping that with our we have a no breach approach. So it's a direct integration. You don't need to worry about assets being staked on the centralized, eventually vulnerable breach. It's very secure. So it doesn't get any more secure than that because there's no breach. So it's something worth trying. So that'll be if there's a call to action I want to share with the audience. And also the other thing, just two things. The other one is I think the Hong Kong is we're trying to become really focused in growing our Asia community based out of Hong Kong. We had a very good trip in Hong Kong 2 weeks ago with our founder Dominic Williams, who made a keynote speech on the Web3 on day one session of the Hashkey and Wanxiang event. We met with a lot of government officials, a lot of investors, a lot of communities and developers who previously, because of COVID and other reasons, just couldn't spend time with Dominic Williams. So the Hong Kong seems to be a really good springboard for the foundation to expand our presence in Asia. So welcome to Hong Kong and welcome to reach out to us. Bring your ideas from the EVM world to IC because we can. I think we can do more of that in IC. So thank you, Paul.
Awesome, Herbert. I don't know you're also in Hong Kong as well.
Oh yeah, I was in Hong Kong, but unfortunately, I was basically with Dom in the hotel room in a Renaissance hotel like all day long in meetings. I couldn't really get much air outside.
Well, next time maybe you'll be in Hong Kong. That I can show you around.
That'll be nice. That'll be nice.
Awesome. Kevin, Ming, and also Jimmy, do you have anything you want to share with our the audience? If for personal view for the market future trends, not only for trading but also for developers.
I think yeah. Currently, as Herbert mentioned, that I think currently Hong Kong narrative is a good sign for the entire industry. I think it is a good time for us to build good projects and explore the more application scenarios for the entire blockchain industry. And so the Conflux actually is now moving our focus to the Hong Kong, and we are trying to extend our global visibility and ecosystem based on the Hong Kong as a hub. And yeah, we really welcome all these ecosystem developers to build the ecosystem together with the Conflux to make the Conflux blockchain ecosystem even better. And so I think Conflux has a lot of advantages to attract more applications. And first, we will soon have the Chinese yuan stablecoin called CNHC on board to participate in the DeFi applications, and this will it could be expected that this will enlarge the TVL and the assets on the Conflux blockchain significantly. And also I think Conflux chain is always works as a only one regulatory compliant blockchain in China mainland. So this is also very consistent with the current Hong Kong narrative. I think we have the similar collaborations with the Hong Kong government, and we and we really thanks very much for the support of Hong Kong government. And yeah, so that's my view on this on this market trend. I think we should leverage the Hong Kong opportunities to to make the area better. Yeah, thanks. Paul.
Cheers, and thank you so much, Ming, for your add-on. So for Jimmy and Kevin, do you also have anything you want to share with our audience?
Not much.
Yes, from my view, I think. Yeah, thanks, Kevin. Yeah, from my view, I think I'm quite optimistic about the future of crypto, especially in the next few years. More and more builders are coming, and maybe some of them may left leave the industry, but more and more solid and legit builders are joining. And we see the progress step by step of the fundamental blockchain, the different layer 1, layer 2, and also different consensus mechanisms and different solutions to make blockchain quicker and safer. And also we see the progress of the from the user side, like the abstract account and also a smart wallet, which could provide them a Web2 user experience with Web3 decentralized and transparent data. So I'm quite optimistic, but for the marketing and trading view, actually, I think this year will be quite fluctuating. The price may up and down because if we see the number of stablecoin, especially for USDT and USDC, this kind of the fiat money back to stablecoin, actually the total number is not increasing. But also they after last year the number is not decreasing very fast, so that means there's not too much new capital into the industry, and especially for now the current stage of the crypto is capital driven. So maybe the market for this year I think will be quite fluctuating, so we all of us need to keep an eye on that and don't use too much leverage. So keep building and to move forward. And I think with the technical progress, the future will be quite bright.
Awesome. Thank you so much, Jimmy, for your last thought. Also, thank you, Kevin, for answering all the above questions as well. So we have two of our audience want to raise hands, and they've been raising hands for so long that they have some questions they want to ask our guests. So I'll invite them to the stage, Lizo, Devi, and also Lara. Hello, Lizo, can you hear me? Or Lara?
Hi, thanks for having me.
Hi everyone.
I'd like
Am I
to
audible?
talk. Hi.
Yeah, sir.
Okay.
Please.
Yeah, thank you very much. Thanks for inviting me.
Lara,
Hi.
give me a sec.
Sorry.
Okay.
Should I go first?
Yeah. Sure.
Thank you. So I'd like to talk to Herbert to learn about his opinions. So Herbert, do you think it is a bit biased to say bridges are bad and evil? Radicals say this quite often. Bridges are bad, bridges should disappear. But have you ever used a bridge? If you have, then I guess there's more pros than cons as people do need it. Bridge is inevitably the region need for the whole Web3. We just need to see it enhance security more and improve the UX more. In my opinion, the concept of bridge is actually quite extensive. For example, multi-chain, they did start as a bridge like 3 years ago, but their causes has been far beyond the narrow concept of bridges, as they do more than just asset bridging. And for all intents and purposes, ICP plays, for me, it plays a role as in a bridge to BTC as well. But anyway, my point is, if you consider bridges are bad, what do you think would be the ultimate solution for multi-chain interoperability? By the way, I don't think ICP is a solution to this, as it only gives access to BTC at the moment. Would be nice to hear about your opinions on this.
Hey, Lisa, right? Thank you for this great question. I think we are right now. We are clearly in the war of narratives. Different terms have different meanings for different people and all that. So when we say, I know, I think did I just tweet about that that you read? When I say bridge is bad, what I mean is the traditional sense of bridge where assets are staked, are stored on a centralized party. And basically, it takes two parties to trust this centralized, let's call it bridge provider, right, to do all the asset swapping and all that. That's what I meant. And then that is just inherently insecure, because when the asset becomes high enough, eventually there is just the temptation to rug pull just multiplies. That's what I mean, right? So in ICP, you are right, Lisa. Right now, we are only able to achieve direct integration with Bitcoin. We are still working on the Ethereum, so we are getting there, but not yet. That is a very accurate description of the state of the union of ICP. But allow me to elaborate a little bit. So the way we achieve, we purposely do not call this a bridge. We call this direct integration, which actually creates all sorts of translation challenges, because there's no centralized single party that will take assets from either side. There's only ICP mainnet and the Bitcoin mainnet. That's all. So, well, essentially, there is, I think I briefly mentioned this earlier on the call, which is somebody initiate a transaction from ICP and with and sign a signature that will be recognized by the other side from Bitcoin, and then Bitcoin can do the same in the reverse direction. I think a lot of protocols will be able to initiate signed transactions that can be received on the other end. The bigger challenge is to receive the message back in the signed transaction. So actually, in Divinity, it took us more than a year to tackle that issue, to finally achieve that. So it's not a trivial effort. And then Ethereum is just even more complicated. That's why it's it's going to take much longer time. So eventually, I do share with you the view that the world is going to be a multi-chain, a world of a multi-chain. There will be multiple layer ones that can serve different customers. So ICP, we actually do see this. There's a place we can play where we can be sort of sort of a layer two. We can sort of a layer two for Bitcoin. We will become another layer two for Ethereum in the coming months, and we are happy to become another layer two, for other layer ones, if that will make the job of the developers easier. But where this will go in the end is hard to predict. But I do agree with I share with you. It is I share with you in the sense that right now, given the lack of a solution, a widespread solution in the industry, bridges are necessary. It's because there's no other way of making asset transfer. But we are hoping that, at least from Divinity side, we will be able to provide a better, more secure solution for the industry that is more than just, that is not a bridge, but rather just a direct integration. I hope that helps, Lisa.
Yeah, thanks. It helps. I think that it's just probably some miscommunications and misunderstandings, because some bridges they are centralized and some are not. Like multi-chain, they use MPC, like validators, right? They're fast MPC. They have set of validators, and they're open to all the community to join as the validators. So yeah, but anyway, to save everyone's time, I'll leave the time to Laura. Thank you.
Yeah, thank you, Lisa. Yeah.
Cheers. Thank you so much, Lisa and Herbert, for answering these questions. Laura, you're up next.
Hello, everyone. Thanks for bringing me up to speak. Actually, it was very informative AMA, I must say, so far. Yeah, as we all know that there is still large audience in the world that has yet to meet the crypto and blockchain industry. So what do you think that will attract new users into crypto spaces, most especially into this Web2?
Well, there seems to be a lot of noise in the background. Hey, Pong, did you get a question? I think the question is about what would it take to attract new users into crypto? Is that right?
Yeah, of course, yeah.
Lara, you back? well, the it seems like the Lara's connections is open.
Hello,
Lara,
can I?
yeah,
Hello, can you hear me? Can I repeat the question?
yeah, definitely.
Okay, yeah. As we all know that there is still a large audience in the world that has yet to meet the crypto and blockchain industry. So what do you think that will attract new users into crypto spaces, most especially into this Web3?
Do you have any guesses you want to ask directly, or
Yeah, it can be anyone. It can be maybe Habat.
Yeah, I can say something. So basically, I think I can think of two things. So one is that we need to improve the user experience a lot because in the Web3 actually we have different ways of communicating with the system. Because for example, in Web3 we users need to use the crypto. Stuff to sign to generate the signature for their transactions. But in the Web 2 area, users will be accustomed to use just the telephone, the phone numbers, and also the emails to interact with the system. So this experience, this using habits is kind of different. So this blocks a lot of users from Web 2 to enter into the Web 3 area. So another thing is that the security stuff, right? If you lost your you lose your private key and your asset will totally lost, and this is also a concern from a lot of users. So currently, I think Conflux actually made some efforts on this direction. Actually, we recently have established some collaboration with China Telecom to work on what we call the blockchain SIM card, blockchain-based SIM card. So which actually integrate the hardware wallet logic into a SIM card. And so this actually, if you have a phone and you attached with this SIM card, BSIM card, blockchain SIM card, then you will immediately got the both the security of the hardware wallet and also the convenience of the software wallet. And we believe that this mechanism and also the collaboration with the telecom, China Telecom, can attract a lot of users of the telecom mobile phone from the Web 2 to the Web 3 area. And another thing is that I think for the is at the application side, I think we should build a lot of applications that can have a more close collaboration connection with the traditional business in the Web 2 area. For example, so we have a lot of business data or even the user data in the traditional internet business stored in the off-chain from not in the blockchain but in the centralized storage servers. And now I think we need to figure out the better way to interact to interconnect these Web3 applications with these Web2 data. And we should find a lot of business that we can make this off-chain data, find a way to make them have the incarnations on the on-chain side, and so that we can enable this tokenized Web2 data to exchange easily in the Web3 infrastructure in the decentralized way. So if that can be achieved, and more such kind of applications can be deployed, I believe more users will come from the Web 2 world to Web 3. Yeah, so that's my opinion for this question. Yeah, thanks, Paul. Thanks, Lara.
Thank you very much. Thanks for the answer.
Hey, Lara, I think that I also want to just chime in a little bit, share my 2 cents. Thank you for this great question. I think this is a very clear and present sort of a challenge facing the entire crypto industry, right? That is, I was with the Hong Kong government official yesterday, who wants to know, how can we grow from here? How can we do, Web3 beyond just crypto? How can we find more use cases for Web3 technology? So I think there's Actually, my answer is going to be both disappointing and also hopefully inspiring at the same time. Disappointing because the solution is very simple. Come to ICP, become a developer in the Internet Computer Protocol, because that's exactly what we are designed to do. We can serve a front end of web applications. We can provide data storage almost in the very, very identical sense of a decentralized AWS, where I came from. I used to be the head of startups for AWS Greater China. I wrote the playbook for AWS globally when it comes to startup strategy. I'm just trying to prove to you that I'm not a dystopian lunatic who wants to disrupt the world and all that. In my opinion, with the rise of Internet Computer Protocol, I mean the fact that we are still growing and striving after our not so admirable launch of the mainnet 2 years ago. The rise of ICP means that most of those Web2 software developer solutions, whether it's TikTok, WeChat, Alipay, you name it, Salesforce, they don't have a reason to exist anymore. They are too old. They are too centralized. The data is not secure. There's no data sovereignty. Everything we embrace in Web3, none of that can possibly be achieved on Web2. But then on ICP, I can give you a list that shows vertical by vertical. We have seen new startups rising that wants to replace the old guard from Web2. For music, you have Spotify, we have Italka. For YouTube, we have the social. For Patreon, Substack, Mira, and the Medium or the WeChat public accounts, we have now Mora. And then for LinkedIn, we have District. And then for World of Warcraft, we have IC1101. For Decentraland and Sandbox, which have top 100 daily active users tops, we have Shiku. All of these applications, they are 100% built on ICP, which means there's no centralized party anywhere. Well, maybe for the domain name. The domain name is still controlled by the 19 rule servers by Icon. That is probably going to be the holy grail by the end of the day, but let's just leave that for now. But everything else, if you build on ICP, can be decentralized. Even this is what just happened a few months ago. Even the control of your application, you can pass that to the DAO that is owned by the community. This just happened with OpenChat. That is a very robust instant messenger application built by only 3 developers based out of London, only 3. And they build this WeChat equivalent IM tool called OpenChat, that oc.app. And they just raised $6 million in February in a very bearish market. Only 3 guys. They raised $6 million on the valuation. Now, on the valuation then was around $25 million. Now it has, because of the trading in the DAX on IC, it has risen to more than 40 million valuation. Only 3 guys, and it only took them a year to build this application. And what they did is they passed the control of the smart contract that essentially controls all the user data, all the APIs of the application to this DAO that is owned by the community, which now has a few thousand members globally. What that means is we will be able to create applications that can persist forever. Basically, you create something, you can be assured that thing is going to last forever, as long as you keep sufficient cycles to power the application. That is actually become a reality now on ICP. Well, all this in the end leads to immortality, which is pretty much the goal, the eventual goal that everyone from Vitalik to Sam Altman or Balaji is trying to pursue. So that is a very exciting future, and I think that goes a lot more beyond in terms of scope. Just what people understand about Web2. Web2 has very limited use cases. I think with ICP, we'll be able to give a lot more use cases. They're just pretty unprecedented. That will take a lot of imaginations. for the developers to unlock and explore. But welcome to to our ecosystem and then try it out.
Awesome. Cheers, Herbert, and also Meng for answering Lara's questions. So with our last guest, 3 questions. Yuna, are you on stage?
Yes, thank you so much, Pon, for inviting me.
Thank you.
Sure, it's interesting because I also wanted to ask about the mass adoption and the roadmap of Complex, and Ming and Herbert have answered the question like pretty perfectly. I'm personally also a fan of Izumi Finance, and I want to raise the same question to Jimmy actually. So Jimmy, what do you think are the most critical factors that will drive the mass adoption of blockchain technology, I guess across like different industries and user groups? I want to hear your opinion on that.
Hi, Jimmy. Hello, Jimmy. Are you here?
Oh, he might be offline, I think, but that's fine.
Yeah, I think yeah, because this Twitter space has been running overtime for a little bit. I think he must have some other busy schedules and have something to also do. Or Jimmy, are you still on the stage? Or do you have any other questions that you want to ask our other of our guests?
I guess just anything about mass adoption. Like I'm just generally interested because I'm still pretty new to Web3. I'm still learning. So just like any insightful opinions on that would be pretty helpful. Like seriously, you guys already did an amazing job today.
Yeah, we're already like contacting Jimmy see if he's available to answer your questions. So if there's any other guesses you want to answer the questions.
I can. I think it's a great question. I can share a little bit. I think the mass adoption, right, is the angle for all of us. So thank you for asking this great question. I think it boils down to the basic. Number one, we need to provide. I think the Ming also mentioned this just now. It's we need to provide great documentation to help the developers. If developers, the first thing is, show me a hello world. How do I do hello world and all that in 5 minutes. So documentation is key. I know it sounds boring, but it's actually not easy to do this right. Especially in ICP, we are often accused of inventing a lot of new terms that are very unfamiliar to our friends in crypto. So guilty as charged. It is the case. So documentation is very important. Dear to the heart to all the developers. And then the other thing is, I think we just need to empower developers to make money. I know that sounds cheesy and all that, but eventually people got to eat. So at some point, I think this is a constant, sort of struggle or dynamics. We are wrangling between the Divinity Foundation and the community, and very very often, we are Divinity Foundation. We are on the receiving end of a lot of complaints and accusations, and why don't you guys do more to help the entrepreneurs in the ICP ecosystem, right, to go to the next stage. So we are working on that. We need to help them raise money. We need to help them, introduce them to the great VCs, Web3 or Web2 in the space. We need to, encourage them to go to Hong Kong to set up their office there so that they can issue tokens without, in a safe, legal environment. So it's all the basic things to help a very early stage entrepreneur. And then the third thing is the third thing for mass adoption is just that I think the industry wise we need to be able to speak to the end of, eventually it's in the beginning it's always going to be the retail customers. So we need to be able to develop certain applications that can be used by like everyday, mom and pop. my neighbors, without imposing them to go through the creation of a MetaMask wallet or all that. So we need to have that kind of application to for crypto to gain mass appeal. It is not easy, but I think we have at least already seen some glimpse of hope. Like one example I briefly mentioned earlier on the call was this Mora, Mora.app. It's called a Mora application where you can, if you're a blogger, you can now publish content on Mora application. And I've been writing for the past, I see myself as a writer and blogger for the past, I don't know, 17, 16 years, since 2005, or maybe more than that. I'm now in the process of migrating a few hundred of articles I've written over the years to Mora. And the beauty of Mora is the founder is adamant about he's not going to issue token. He's not. He's like, I'm not doing any airdrop. I'm not doing token because I want to prove, because his name is Peter. He came from Web2. He's a very accomplished product manager from the Web2 era. He's like, I want to prove to everyone that I can create a bona fide, well-crafted Web3 application without using token. And I think he's, based on the extremely enthusiastic response from the community in ICP in the last 2 weeks since he launched the production version of Mora. I think he's achieving that. There's no token, but then you pay for what you want to read. It's that simple. So it's happening. The revolution is happening, but it's still very early days. So it's gonna take a while for us to get there. But we should start trying. But thank you, Luna, for the great question.
Thank you so much. That's amazing. I can see that you're like putting in genuine effort to like engage more people in the Web3 space, and I appreciate your answer about building a community, because it costs like so much effort to build a great community. So cheers to you guys, and cheers to you, Herbert.
Thank you, Yuna.
Cheers, Yuna, and also cheers to Herbert. Jimmy, it seems like Jimmy having some technical issues with his connections. We just texted him. So if there's any communications or questions that you want to ask, you can directly send DM to Jimmy to ask with your questions. So because the time has been running out for over an hour, almost an hour for today, and our guests have the busy schedule and they have meetings coming up soon. So I would appreciate for everyone else to come onto the stage today and being honored to be here, become the host with you guys. And thank you so much. And I hope to see you guys next time and around this Web3 channel. And thank you so much, guys. Have a great day. And that's a wrap for today's.
Thank you so much, BTS Labs, and thank you, Pong, for hosting this great event. Thank you all.
Thank you. Thank you.
Cheers, guys.
Cheers.
Cheers. Thank you.